So here are our givens. They're marked on the diagram already. I've got the parallel arrows to show that AB is parallel to DC. I've marked that AB is congruent to DC. I'm trying to get these two triangles, these internal triangles, this one here in red, this one here in green, to be congruent. Before I do my two-column proof, let's talk for a while. I've got one out of my three necessary facts already in my givens. Where can I get my other two facts? Take the easy ones. Are there any shared sides? Yeah, DB or BD. It's congruent to itself. Something else you guys want to get in the habit of doing is marking up these pictures. Don't just look at it. As you notice that you can prove things, make a mark on the diagram to show that that's something we're going to be using. I'm also going to give you guys a hint here. We're going to use side angle side for this. So it kind of helps guide our direction. So I've got my two pairs of sides. Here's one pair of sides. Here's two pairs of sides. Another trick that sometimes helps students is to actually draw the two triangles split. So here's A, D, B, D, B, C. And now I can say I've got these guys marked as the same. These guys marked as the same. I just need to get a third fact into play. It's actually going to require me to go back to this picture to get it. Where's that third fact? Have I used all my givens yet? No. I've used the this fact. Well, that's one of my part of my plan. I'm going to use that in the actual justification. I've used the congruent. Haven't used parallel. If AB is parallel to DC, does that tell me anything?
Oh.
What's up? Yeah? Alternate interior angles, right? That's going to be right here and right here. So that would be this angle and that angle. So if I look down here, I've got one pair of angles, two pairs of angles, sorry, one pair of sides, two pairs of sides, and I've got the angle between them. That's a side angle side. Two sides and the angle between them. We're done. All I gotta do is write it. There are a couple of these from scratch proofs tonight, so there is something to be said for going through it slowly, step by step, mapping it backwards, making sure everything works. So let's see. AB congruent to DC. That's one of my two givens. So it goes at the top. AB parallel to CD. That's also given.
I have a quick question.
Yeah.
How do you determine if it's like angle side angle or side angle side? Or...
The biggest trick to picking which theorem we're talking about has to do with the relative position of your sides and your angles. So for example, in this one, I've got two pairs of sides. So I'm going to be dealing with side, side. And the angle is located between those two sides. So that would be side angle side. If later on you're looking at something where you've got two angles, the side's either going to be between them. So that would be something like this. Or it's not going to be between them. So I'll have two angles and the side not between them. The other way to kind of, and these are the two hardest to keep straight. This one, you know it's side angle side because I've got two sides and an angle, and it's the only rule I'm allowed that involves two sides and an angle. You just have to make sure that angle is right where it says it is, nestled comfortably between those two sides. Not too close. I mean, this is a general audience program, but close enough that it's there. All right, so we said parallel. From parallel, we talked about the fact that I've got these angles congruent. So angle ABD is congruent to angle BDC. There's an angle sign in there. Because they're alternate interior angles. That comes from, alternate interior angles, that comes from the lines being parallel. We also introduced fresh to the picture that BD was congruent to itself by the reflexive property. And now my last step, triangle ABD is congruent to triangle CDB by side angle side.